So eventually this will go on to page 58 of your notebook. So based on the activity you just completed, explain the patterns that you observe by filling in the blanks to develop different rules. Okay, so that's what we're going to do. So when a quadratic equation is in the form y equals x squared plus k, where was it y equals x squared plus k? On the top or on the bottom?
The top.
The top. Y equals x squared plus a value, plus or minus a value. Okay? So when it was y equals x squared plus k, where k is a constant just means a number, whole number, describe the translation. So if k is greater than 0, the parent function translates which direction? So if you have to look back, when k was greater than 0, so you had a plus something, what way did you shift? Up, right? So if it was plus 3, plus 5, they all shifted up in that top section. Do you see that?
Yeah.
So plus 1, it shifted up. Plus 2, it shifted up. Plus 4, it shifted up. Okay, so if k is greater than 0, you're going to have a shift up. What if k is less than 0? It's going to shift down. That was the minus 3, minus 5, whatever you have there, but it's going to shift down. When we had the quadratic equation y equals parentheses x minus h squared, where was that at the top or the bottom of our activity? The bottom. H is a constant number. What happened? So when h was positive or greater than 0, so when you had a plus 4, which way did it shift?
To the right.
Let's look back. So I had a plus 4, it shifted to the left. A plus 5 shifted to the left. So this should be to the left. When h was less than 0,
Shifted to the right.
it shifted to the right. So we had that negative number. Here. We had x minus 2 equals 0. It changed and it shifted to the right. Okay. So let's fill in some of these key features. I'm going to add something else to the top in a second. What determines if the graph is skinny or wide, or there's a compression or a stretch? I need something a little more specific. What determines if it gets skinny or wide? A. The A value determines if it's skinny or wide. If it's skinny, remember it's a stretch. If it's wide, it's a compression. What determines if the parabola opens up or down? The orientation. What determines if it opens up or down? What value? So let's look back here. How did we know? So let's look at the difference between, I don't know, these two here. What told me it opened up or down? This one opens up, this one opens down. How do I know? How do I know that this one opens up and this one opens down? One's negative, one's positive. But what value is that? It's your A. A is negative 1, A is positive 5/3. So A also determines if it opens up or down. If A is positive, which way is it going to open? If A is positive, should it open up or down? Up. Everyone should probably write all of this information down. If A is negative, it's going to open down. Okay. This next one is new information, but let's see if we can come up with it. Blank and Blake determine the vertex. So I want you to look at this equation and think about the front side. What determines the vertex? When you whisper, I can't hear you necessarily, so. What in the equation determines the vertex? Okay, so this number determines the vertex. What changed when I had a K? What changed when I had a K value on my vertex? The Y value changed. So K is your Y value. So K is the Y value. And when I had the K's, did the sign change or did they all stay the same? So if you look back at the front, if I had x squared plus 3, what was my vertex? It was a plus 3. So my K value stays the same. If it's positive, it stays positive. If it's negative, it stays negative. So what gave me my X value? H. What was in the parentheses, but what did we notice there? If it was a negative, it became a positive. So this one is opposite. So if you have a positive, it becomes a negative. If you have a negative, it becomes a positive. So then what determines your axis of symmetry? Your X, so our H, which is the X value of the vertex. So we're going to go through all of the different pieces. So before we actually look at graphing, who can remind us what standard form is? Good. Y equals ax squared plus bx plus c. We have been dealing with standard form this entire last 2 months. We're going to be looking at something called vertex form. And vertex form is a times x minus h squared plus k. I should probably put y equals. So y equals a times x minus h squared plus k. So what does a tell me? What can I determine just by looking at a? If the graph is skinny or wide, and if it opens up or down. I don't have to graph it to know that. What does h tell me? What part of the vertex? The x value of the vertex, and h is always opposite. What does k tell me? The y value of the vertex, and it's always the same. How do I find the axis of symmetry? With my h. I look at my x value of the vertex. There is zero math to identify all those things. And if you can identify all of those features and your graph doesn't look like those features, something's wrong. Everything should match up. Okay, so before we even graph, we're going to identify some of this information. Okay, so let's look at problem 1. Our equation is x squared minus 2. Our equation is x squared minus 2. What do we think the vertex is? And I see some of you using the computer, and that is just fine.
0, -2.
0, -2. So let's look at why it's 0, -2. So if I come back up here, do I have parentheses?
No.
No. Which tells you there is no, or your x, it tells you your x value is 0. If there's no parentheses, your x value is 0. Do I have something added or subtracted at the end? Yes. That's this piece here. So that's where I get -2 from. Here's why, and I'm going to show you in a second why this is going to be important to us. But let's fill in some of this information before we even graph. So I know my vertex is 0, -2. Everyone okay how I got that? So this is K, and there's no H shown. What is the axis of symmetry? X equals 0. Fabulous. It is the x value of your vertex. What's the domain?
All real numbers.
Great. We don't have to think about it. Okay, this O stands for orientation. What's the orientation? Does it face up or down? Up. It's a positive. So it faces up. What's my A value? What does A actually equal? 1. So is it a compression or a stretch, or is there no change? No change. Okay. If it faces up, do I have a maximum or a minimum? A minimum. Okay, and this is, I don't like how it's written, but this is going to be our minimum value. Do you remember when we talked about minimum value? What is the minimum value? -2. It's the y value of your vertex. Okay, so my minimum value is -2. Last thing we have to fill in is range. So if I have a minimum and it faces up, all of my y values become greater or smaller? Greater. So y is greater than or equal to what? -2, the y value of your vertex. Do you see how I filled everything in without graphing? Now, if my graph doesn't match that, then we have an issue. But here's why we have to find some of this information first. Yesterday, I gave you a table of values of -1, -2, -1, 0, 1, and 2. That will not always be your table of values. Here's what I want you to do to create your table of values. Sometimes it will, sometimes it won't. So draw your table. Our middle point is going to be the vertex. And what did we learn about the graph around the vertex? What do we know about the points around the vertex? They're what? They're the same. They're symmetrical. So as long as you pick the correct points, you're good. So let's pick 2 points above and 2 points below. So 0, and then I have -1, -2, so it happens to be the same points, and 0, 1, and 2. But whatever I plug in for -1 will be the same if I plug in 1. Whatever I plug in and get for -2 is the same if I plug in 2. So let's not do the negatives, right? Let's deal with positives. So if I plug in 1, 1 squared is 1, and 1 minus 2, 1 minus 2, -1. Okay, so once again, so 1 squared is 1, 1 minus 2 is -1. Well, if I plug in -1, guess what? I'm going to get the same answer, so why am I going to plug it in twice? Okay, so let's plug in 2. What's 2 squared? 4, and 4 minus 2 is 2. Well, if I plug in -2, guess what? I'm going to get the same answer. Okay, so now when I plot my points, it should face up, and it shouldn't be skinny or wide, it should be normal. If it's not, we either did something wrong on our graph or we did something wrong here. So let's see what happens. Let's plot those points. So -2, 2, -1, -1, 0, -2. And then again, it's all symmetrical if we did it properly. You'll see that the points literally match up. Does your graph look like that? Yeah? Awesome. No? What are we missing? Yes?
Isn't it, aren't they like, on the X, like spaced by 2?
Yeah, that's what
Oh, it is. Yeah, I just did it based off of ones. Just do it based off of ones. But thank you for noticing the scale. I can't see those numbers. So some of you noticed the scaling, some of you didn't. If because of the scaling being wider, so it goes by 2, your graph's going to look wider than it needs to be, but let's just go with a scaling of 1. We're going to do with a scaling of 1 with all of these. They should all fit. But awesome way to notice that. I did not notice that. If you notice it and your graph looks slightly different because it's wider, that's okay. Okay. Are we okay with that? Let's look at our next one. I have something in parentheses, so what value is that? H or K? H. And remember, H is opposite. So what is that actually going to be? -3, and that's the X value. Do I have anything attached at the end?
No.
Nope. So my Y value is 0. That's your vertex. So remember again, if it's inside parentheses, it's your X value, and it's always opposite sign. So because it's a +3, it becomes a -3. Right, but you're just looking, see up here? You just look at this. The X you don't worry about, it's just the constant. Okay, so it becomes a -3. There's nothing attached at the end, so it's a 0. Everyone okay with the vertex? Because once we know the vertex, the rest kind of falls into place. What's the axis of symmetry?
X equals negative.
X equals -3. What's the domain?
All numbers.
All real numbers. I'm going to come back to the reins. What's my orientation?
Down. Wait. Oh.
Up.
Yeah, it's +3.
It's positive. What's the shape? No change? Do I have a maximum or a minimum? Minimum because it faces up. And what is my minimum value? 0. It's the Y value of your vertex. So if everything faces up, it's Y is greater than or equal to 0 for my range. Okay, my table of values is going to change now though. So let's create a table. My middle point is -3, 0. What two numbers are less than -3? -4 and -5. And then greater than -3 are -2 and -1. So now my table is different than what we've been using. Which number would you like to plug in? -5. Okay, so if I plug in -5, -5 plus 3 squared. What's -5 plus 3?
-2.
And -2 squared?
4.
4. So if I plug in -5 and I get 4, what else could I plug in to get 4? Remember, it's symmetrical. So if you want to plug them all in, go by all means do so, but it's going to have symmetry. Let's plug in -4. -4 plus 3 is what? And -1 squared is 1. Yes, Tyler.
How'd you get the X value?
So to get the X values, you start with your vertex. That's your middle point. And then you pick 2 points below and 2 points above from the X. Okay. Again, let's use the scaling of one box, because if not, it won't fit. So let's plot negative 5, 4, but count each as one box. The graph should look something like that. Once you're done with the third one, I want to see how much, or of the second one, I want to see how much of the third one you can do. So go through and identify all those things and try to create a table of values and plot, and then we'll go over it. Vertex. So first of all, is there something in parentheses?
Yes.
Yes, so that's my H, and H is opposite. So you should have negative 3. Outside of parentheses is my K, and K stays the same. So you should have negative 2 for your negative 3, negative 2 for your vertex. So far, so good?
Yeah.
Okay. Axis of symmetry is the X value of your vertex, so X equals negative 3. Domain, all real numbers. Orientation, up. Shape, no change. There's no, the A value is 1, so you can leave it as is. Maximum or minimum? Minimum. And what's my minimum value? Negative 2. So if it's a minimum, it's Y is greater than or equal to negative 2. Do you notice how all of our numbers are the same for the most part, right? It's either negative 3 or negative 2. It's either the X or the Y. So if you get something other than that, you need to go back and fix it. So if I create a table of values, my middle point is negative 3, negative 2. What are two numbers that are less than negative 3? Negative 4 and negative 5. And two numbers that are greater are negative 2 and negative 1. Okay, what should we plug in?
The negative 5.
Okay, so my vertex is negative 3, negative 2. So I choose two numbers below negative 3 and two numbers above negative 3. Okay, so if I plug in negative 5, negative 5 plus 3 squared. So negative 5 plus 3, negative 2 squared, and 4 minus 2 is 2. What else is going to be 2? If I plug in negative 1. Okay, let's plug in negative 4. Negative 4 plus 3 squared. What's negative 4 plus 3? Negative 1. Negative 1 squared. 1 minus 2, negative 1. Okay, again, let's use them as individual boxes. So negative 5, 1, 2, 3, 4, 5, 2. Oops. Negative 4, negative 1, negative 3, negative 2, and then it's symmetrical. Is my vertex at negative 3, negative 2? Yep. Does it face up? Yes. Is it a normal graph? Yes. So those are all the things that you want to check for as you go through. We're literally going to be spending the rest of the semester on graphing. So you have to be able to identify the features. Questions, comments, concerns? No? Okay. I've given you your homework. There are 4 questions. You need to identify all the features just like we did, and you need to graph.